Okay, in this video we are going to take a look at how to solve basic projectile range question. So the question is here that an object is launched from the ground with an initial velocity of 30 meters per second in a direction 21 degrees above horizon. We have to find the range. If I draw a diagram of this projectile motion, it will be like this, where this is my initial velocity, which is 30 meters per second, and that is my launch angle, which is 21 degrees. Now in previous videos we have seen that whenever there is a motion in two dimensions, we can analyze or calculate specific aspects of the motion in two mutually perpendicular directions independently of each other. So that's what we are going to do. We are going to analyze this projectile motion by considering motion in two mutually perpendicular directions. So we will consider this motion in vertical direction, and then we will consider the motion in horizontal direction. And because they are at 90 degrees with each other, these two motions will be totally independent. So to say, they will be totally independent, because velocity in one dimension, suppose this is the x direction or horizontal direction, velocity in this direction will not affect motion in this vertical direction here. Okay, now I want you to pause the video for a moment here and try to think about which factor would affect the time of flight of this projectile. So we are launching this projectile from here with this initial velocity. This projectile, it goes here, follows this path, then it lands back on ground here, and it takes, say, t time, and this time is known as the time of flight. I want you to think for a moment as to which of these two motions, horizontal or vertical, would determine the time of flight. And if you think a little bit, you will see that because of horizontal motion, the projectile here, this projectile here, will keep on going in horizontal direction. It will keep on going forever, because the velocity is not affected in horizontal direction. It's the vertical direction which takes the ball up from this ground. It takes to the highest point here, and then it brings it back to the ground. And this vertical velocity, this vertical motion, when it brings the ball or object back to the ground, your flight ends. So your time of flight is, I'll write this it's right here because it's a very important thing to keep in mind. The time of flight is determined by the vertical motion. All right, so this is what we're going to do. We'll consider the vertical motion here. So I'll write this here, considering vertical motion. I want you to pay particular attention to how I am presenting the solution, and I would recommend that you also try to follow the same presentation style. So when we are considering vertical motion, we have to consider the vertical velocity of our projectile. So my projectile is going like this. This is the initial velocity, 30 meters per second. So I need to find what is the vertical velocity. So I need to find the vertical component. This angle is 21 degrees. So the vertical component here, that would be 30 sine 21. And if you put that in calculator, you find out it will be 10.75 meters per second. Okay, so we will consider the vertical motion, and we will be using one of the equations. So but let me first list the quantities that I have for this vertical motion here. U is my initial velocity, which will be, let me write it again here, 30 sine 21, which is equals to 10.75 meters per second. And the fact that I have taken this vertical velocity as positive here, it means that I am taking the upward direction as a positive direction. All right, acceleration is acceleration due to gravity, and it is downward. So because my upward direction is positive and acceleration is downward, I will be taking that as minus 9.8 meter per second square. And then I'm considering the whole motion of this projectile. It's starting from this point A here and finishing at this point B here. And when I look at this, motion in the vertical dimension, I find that object is starting at height equal to 0, and it comes back and lands back at the horizontal point. So vertical displacement in this time is 0. Object went up and came back down, and vertically it was at the same time when the flight ended. So that gives my s equals to 0, and I need to find the time. And this is the time which we are trying to calculate, which the object is taking to go from A to B here in our horizontal direction diagram here. When you look at these quantities, you should be able to see that we will have to use the equation s equals to ut plus half at square. Substituting these quantities, I get s equals to 10.75 t minus half 9.8 times t square, which will become 0 equals to 10.75 t minus 4.9 t square. I transfer both these quantities to the left, and it becomes 4.9 t square minus 10.75 t equals to 0. This is a simple equation. I can take out t common from both these terms. So t equals to t bracket 4.9 t minus 10.75 equals to 0. And because this is a product of two things, so this equation gives me two solutions. One is t equals to 0, and other is 4.9 t minus 10.75 equals to 0. This is the first solution, and the second solution is we need to solve this equation. I transfer 10.75 to the other side. I get 4.9 t minus equals to 10.75. Dividing both sides by 4.9 will give me the second solution, and this is 2.194 seconds. So we see that there are two solutions. One solution is t equals to 0, and other solution is 2.194 seconds. So these are the two times when the object is on the ground, right? And obviously, I mean, t equals to 0 is the initial time. I mean, this is a time of launch, and obviously the object is on ground at this time. And when it comes back to the ground, the time is 2.194 seconds. So that basically gives me my time of flight. All right, so once I had to come back here now. I got my time of flight now. Time of flight equals to 2.194 seconds. And all this while, what is happening in the horizontal direction? Now, our object has got a horizontal velocity as well. We haven't found that, so let's find that horizontal velocity. Which is equals to 30 cos 21, and that will be 28.007 meters per second. So all this while, the objective is in flight for 2.194 seconds. All this time, the object has got a horizontal velocity as well. The object is traveling with a velocity of 28.007 meter per second horizontally. So all this time, the object is traveling. And when the object lands on the ground after this time of flight, our flight ends. So all we need to find is how much distance, horizontal distance, the object covers in this time. It's a constant velocity problem because a equals to 0 in horizontal direction. It's a constant velocity problem, so all we need to find is how much the horizontal distance is traveled by an object, and that is your That's your range is equals to velocity times time. So 228.007 times 2.194 second, and that gives you 61.45 meters. And this is the range, and so this basically is the distance that the object would cover on the ground. So distance from A here to B here will be 61.45 meters. Just keep in mind, I just want to reiterate here, we already talked about vectors in previous two videos, but I want to reiterate here, I want to repeat here, that when you're considering horizontal motion, then you are talking about horizontal velocity, horizontal acceleration, horizontal displacement, and all those and other things. When it's vertical, when you're considering vertical motion, you're looking at vertical velocity, vertical acceleration, vertical displacement, and other things. The thing that connects the two motions here in the projectile question is the time of flight. So what we do, we find the time of flight using vertical motion, and then we find the range using horizontal motion.